Okay, today we are starting Unit 4. Unit 4 is all triangles. Today we are starting with right triangles and talking about the 6 main trig ratios. The first 3 you should know, sine, cosine, and tangent. You should be familiar with those from geometry. Cosecant, secant, and cotangent, those will be the 3 new ones for today. So looking at this triangle, it says use the right triangle to fill in the requested information. Now, on a triangle, we use capital letters to represent the angle. So up here, capital A represents angle A, which is right here. And here's angle B, here's angle C. Now, angle C is our 90-degree angle. And the side opposite of the 90-degree angle is going to be our hypotenuse. Now, sides, we use lowercase letters, and it's going to correspond to the same letter as the angle. So if this is angle C, then the side opposite will be side C. So for the hypotenuse, it needs to be a lowercase c. Now, the legs of the triangle. The legs of the triangle are the 2 pieces that form the right angle. So the 2 pieces, or 2 legs, that form the right angle are these 2 sides right here. And I need to label these 2 sides. So the side opposite of angle A would be side A. So this needs to be a lowercase a. And the side opposite of B needs to be a lowercase b. So the legs are these 2 pieces that form the 90-degree angle. So our legs are B and A. And I'll write that alphabetically, A and B. Now the leg opposite of A is already labeled for us, and the leg opposite of A would be lowercase a. And the leg opposite of angle B would be lowercase b. And what is the adjacent leg? What does adjacent mean? Next to. So if I'm looking at angle A, the 2 lengths that make up angle A are this vertical piece and this piece right here. Now, they only want one answer, and they're looking for what's called the leg. Well, one of those is the leg, the other is what? This is the hypotenuse. So they're not looking for side C, they're looking for this side, which is B. So the leg adjacent to angle A is side B. And the leg adjacent to angle B, so now if I look at the 2 sides that make up angle B, angle B is formed by the horizontal segment and the hypotenuse. So the adjacent leg would have to be this side right here, and that is side A, so lowercase a. Now, as far as sine, cosine, and tangent, most of you are familiar with SOHCAHTOA. And using that acronym SOHCAHTOA, what does the S stand for? Sine. And sine is opposite over hypotenuse, and here's that ratio here. And C stands for cosine, and how do you find the cosine? Adjacent divided by hypotenuse. And T stands for tangent, and how do you find the tangent? Opposite over adjacent. So you should be familiar with these 3. You should already know how to find sine, cosine, and tangent of a right triangle. Now the 3 new ones are going to be over here in the 2nd column. And the first new one is called the cosecant. And the cosecant is just a reciprocal of sine. And we abbreviate cosecant with CSC. So to find the cosecant of an angle theta, it's 1 over the sine of theta. Now, to find the reciprocal identity, if the sine is opposite over hypotenuse, how do you find a reciprocal? You flip the fraction. So instead of opposite over hypotenuse, the cosecant would be hypotenuse over opposite. So for these reciprocal identities, you invert the fraction. So sine and cosecant are reciprocal. Next pair, we have the cosine of theta. Its reciprocal is called the secant. And we abbreviate secant with SEC. And to find the secant, it's 1 over the cosine. That's how you can find the reciprocal. Or, over here, use this inverse of fraction. So if cosine is adjacent over hypotenuse, the reciprocal would be hypotenuse over adjacent. And the last new one for today is cotangent. And cotangent is a reciprocal for tangent. So if the tangent is opposite over adjacent, then the cotangent would be adjacent over opposite. Now, tangent and cotangent, those are pretty straightforward. Well, let me go ahead and write it out like the others. So to find this, not tangent, this should be cotangent. To find the cotangent, it's 1 over tangent. Now, these reciprocals have to be paired together. Sine has to be paired with cosecant. Cosine has to be paired with secant. Now, tangent, cotangent, that pairing's already pretty self-explanatory. But here's really pretty much the only way to remember that sine and cosecant are paired together. So notice we just look at the first letter. First letter of sine is S. First letter of cosecant is C. If you look at cosine, the first letter is C. If you look at secant, the first letter is S. So the C's and S's make a pair. So sine with cosecant and cosine with secant. That's really the only trick you can do to remember those pairings of those reciprocals. Okay, now utilizing those values. Now it says to write a trig ratio for each and reduce to simplest form. So make sure you do simplify if it can be simplified. So for the sine of A, remember SOHCAHTOA. To calculate the sine, we need to have the opposite and the hypotenuse. So make sure you're looking at the correct angle. So we're just looking right here at angle A. So for angle A, what is the opposite side? 6. And what is the hypotenuse? 10. Does that simplify? Yes, that simplifies to 3/5. So make sure your answer is in simplest form. Next one, we want the cosine for angle A. So for cosine, cosine is adjacent over hypotenuse. So the adjacent side would be 8. I agree, so that would be 8 over 10. And 8 over 10 simplifies to 4/5. And the next one, we want the tangent. How do we find tangent? Opposite over adjacent. And what's the opposite side for angle A? 6. And what is the adjacent side? 8. And 6, 8 simplifies to 3/4. Now, notice over here, we have the reciprocal. So if you have sine, the reciprocal would be cosecant. So to find the reciprocal, we just need to invert the fraction. So if the sine is 3/5, the cosecant would be the reciprocal, which would be 5/3. Cosine and secant, those are reciprocal. So if the cosine is 4/5, what would the secant be? 5/4. Tangent and cotangent are reciprocal, so if the tangent is 3/4, what would the cotangent be? 4/5. So that's everything for angle A. Now the next and the last two questions are for angle B. So we're looking right here at angle B. And how do you find sine? Opposite over hypotenuse. So which side is opposite of angle B? 8. And what's the hypotenuse? 10. And 8/10 simplifies to 4/5. Now sine and cosecant, those are reciprocal. So if you know that the sine is 4/5, what would the cosecant be? 5/4. Next one. Now we have another triangle, But notice we do have a side that's missing. So if you have a side that's missing, you'll have to do Pythagorean theorem to find it. So a squared plus b squared equals c squared, and we're solving for c, which is always the hypotenuse. So this would be 3 squared plus 3 square root of 3 squared equals c squared. 3 squared is 9. And what's 3 square root of 3 when you square it?
3.
It would be 9 times 3, which would be 27. And 9 plus 27 is 36. So what's the value for C? 6. Technically it's plus or minus 6, so could a side at least be negative? No. So here I'm missing piece is 6. So this is actually a 30, 60, 90 triangle. So remember your x square root of 3, 2x. You remember that from your geometry days? Yeah, that was a shortcut, if you noticed. But if you didn't, Pythagorean theorem works still. Now, looking at angle T, we look at cosine. How do you find cosine? Adjacent over hypotenuse. And what's the adjacent side for angle T? 3. And what's the hypotenuse? 6. So 3, 6 simplifies to 1/2. Now we want the cosecant of R. Cosecant, what is the reciprocal of cosecant? Sine. So if sine is opposite over hypotenuse, how would you find cosecant? Hypotenuse over opposite. Make sure you flip the fraction. So instead of opposite over hypotenuse, the reciprocal would be hypotenuse over opposite. So what is the hypotenuse? 6. And what is the opposite side? 3. And 6 divided by 3 is 2. Next one, we want the sine of angle T. So how do you find sine? Opposite over hypotenuse. And what is the opposite side for angle T? 3 square root of 3 over 6. Does that simplify? Yeah, square root of 3 over 2. And then we want the cotangent of T. Cotangent is paired with which other one? Tangent. So if tangent is opposite over adjacent, what would the reciprocal be? Adjacent over opposite. So for angle T, what is the adjacent side? 3. And what is the opposite side? 3 square root of 3. What happens with those 3? They cancel, so this is just 1 over square root of 3. Can I leave a square root in the denominator? No, we need to rationalize that. So to rationalize that, multiply both the numerator and the denominator by square root of 3. So make sure you rationalize. Do not leave radicals in the denominator. So when you simplify, this would be square root of 3 over 3. Next one, cosine of R. How do you find cosine? Adjacent over hypotenuse. And what was the adjacent side for angle R? 3 square root of 3. And what is the hypotenuse? 6. And that simplifies to what? Square root of 3 over 2. Tangent. How do you find tangent? Opposite over adjacent. And what's the opposite side for angle T? 3 square root of 3. And what's the adjacent side? 3. And when I simplify that, what would it be? Square root of 3 is right. And for that last one, we're still looking for tangent, which is opposite over adjacent. And for angle R, what is the opposite side? 3. What is the adjacent side? 3 square root of 3. Now that does simplify, but notice we already did that one over here. So I don't have to redo the same word. What is this answer in simplest form? Square root of 3 over 6. Now, on the next page, now this is pretty much all calculator work from here forward. So we need to make sure we can operate these calculators. Now, a degree can be broken up into minutes and seconds. You really don't have to memorize this, but every degree, so if you have 1 degree, is equal to 60 seconds. And we use 2 apostrophes to represent a second. So anytime you're dealing with a second, we use 2 apostrophes for a second. And in that second bullet says that every minute, and we use a single apostrophe for 1 minute. So 1 minute has 60 seconds. So a minute, we use 1 apostrophe. Seconds, we use 2 apostrophes. Now, will we be using that throughout the rest of the semester? No, but it's required that I teach it to you. So here's a concept we're learning it. So a degree can be broken up into minutes and seconds. So it's just broken up into pieces. Now, we're going to use a calculator to do all this conversion for us. So the first step, it says to convert to decimal degrees to the nearest hundredth. So we need to round our answers to 2 decimal places. It says make sure your calculator is in degree mode. So the first thing you need to do is make sure that calculator is in degree mode. If we're using an 83 or an 84. Now, to change the mode, or to change it into degree mode, you'll hit the mode button, and it's right there on the second row of buttons. It's represented by the second key. So hit mode. Now, when you clear the calculator's memory, the default settings is for it to be in radian mode. So make sure you arrow down to that 3rd row and make sure that degree is highlighted. So the default setting is for radian. So the next time we take a test and I clear the memory, yours will automatically be in radian mode. So make sure you change it to degree mode if necessary. So make sure degree is selected, and to exit, just hit second mode. Now, number 4. What does this number mean? Well, we all know what this symbol means. What is this symbol? 52 degrees. And then the rest of it is broken up into minutes and seconds. So if you see 1 apostrophe, that stands for minute, and 2 apostrophes stand for second. So if you were to actually say this, or read it out loud, this is 52 degrees, 16 minutes, and 32 seconds. So that degree has been broken up into degrees, minutes, and seconds. Now we're going to estimate what this would be to the nearest hundredth place. So we are actually going to use degrees, minutes, and seconds on the calculator. So if I were you, I would make a note somewhere out here in the margin. So if you have a degree, to put the degree symbol in an 83 or 84, you need to do second. So hit the second button, and then the at button, and then number 1. So to put a degree symbol in the calculator, second, at, number 1. To put a minute into the calculator, and a minute is just 1 apostrophe, you'll do second, at, and then number 2. And the last one is for a second. And for a second, we use 2 apostrophes. And it would be nice if there was second at number 3, but it's not. This one's different. This is the only different one. And to type a second, you'll have to hit the alpha button, which is the green button on the calculator, and then the plus sign. So alpha and then plus sign will give you the second. Okay, so now all we have to do is from here forward for this section is just type in exactly what you see in the calculator. So for the degree symbol, do second apps number 1. For the minutes, do second apps number 2. And for the seconds, you need to do alpha followed by the plus sign. So I'm going to switch to the Elmo so you can see what it looks like as you're typing these in. Okay, so the first part, type in the degree. So type in the 52 first. So we're starting with the 52. And then for the degree symbol, it's second apps number 1. So let me show you where the buttons are. Here's the second button. Here's the apps button. And then number 1, you should know where that's at. So hit second, apps, and then number 1. So after you do second apps number 1, notice you'll have the degree symbol. So after the 52 degrees, we have 16 minutes. So type in 16. And then for the minutes, you need to do second, apps, number 2. And now we need our seconds. So we need to type in 32. And then for the seconds, you need to hit alpha. And alpha is the green button. So hit alpha and then the plus sign. So alpha followed by the plus sign. So make sure what you typed in looks exactly like what you see on the paper. So 52 degrees, 16 minutes, 32 seconds. And then hit enter. Now they said convert to decimal degrees to the nearest hundredth. So if I'm rounding my answer to the nearest hundredth, what would it be? 52.28 degrees. So number 4, the answer is 52.28 degrees. You have to have that degree symbol. If they want your answer in degrees, you have to have that degree symbol. So make sure you have the degree symbol in your answer. Okay, I'll do the next one with you, then I'll have you do the rest for practice. And we'll check your answers in a moment. Now the next one, we have 58 degrees. So type in the 58, and then second, apps, number 1. Then we have 32 minutes, so 32. Then for the minutes, it's second, apps, number 2. Now does this one have any seconds? It doesn't have any seconds. If you don't have any seconds, you don't have to worry about it. But technically, this one has 0 seconds. If you want to type in 0 seconds, you can, but it's not necessary. Now, hit enter, and we're rounding to the nearest hundredth. And what would our answer be to the nearest hundredth? 58.53. And don't forget the degree symbol. Now I want you to type in the rest of this section. So I want you to do 6 through 10, and we'll check your answers here in just a minute. got an answer for number 8? Nobody got an error message?
Yeah, I'm not there.
If you got an error message, there's a problem. We have negative 263 degrees. And what is this 49? Seconds. So what is it missing? So it's actually 0 minutes. So if you got an error message, type in the 0 minutes with that. Okay, let's check some answers. Number 6 was 134 point what? Yes, 28. So 134.28. Don't forget your degree symbol. You have to have that degree symbol. Number 7 is negative 43 point what? 40 degrees. Don't forget that degree symbol. Number 8, if you got the error message, then put in the 0 minutes. It's okay for you to have 0 seconds, but if it has 0 minutes, some operating systems don't like it. So this is negative 263 point what? 0.1 degrees. Number 9 is 14 point what? 0.45 degrees. And do you got number 10?
Yes.
Number 10 is negative 24 point what?
Negative 25.
Well, what did you get before you rounded?
0.9. 9 repeating.
Is 0.9 repeating?
Negative 24.999, then a bunch of fours.
9994 repeat.
0.999 and then the 4 repeat?
Yes.
So, rounding back to the nearest hundredth, it's not going to be negative 24.99, it would round up to what? Negative 25.00. Questions on that section? Now for the next section. This one says convert to degrees, minutes, and seconds, and it says use DMS on your calculator. Well, DMS stands for degrees, minutes, and seconds. So when it's telling you to use DMS on the calculator, you have to go to seconds, at, and number 4. So for degrees, minutes, and seconds on the calculator, you need to do second at number 4. Now, step 1, you need to type the problem in. So step 1, type the problem in. So you need to type in 34.79 degrees. Step 2, then once you have that typed in, then you convert to degrees, minutes, seconds. So you would do seconds, and then at, and then number 4. And when you go to the menu, when you do second at number 4, that has this triangle, and then the DMS. This triangle means you should have typed in something before you got to this menu. So make sure you type the problem in first, and then do second at number 4 to convert it to degrees, minutes, and seconds. Now let me switch over to the Elmo so that I can show you what it looks like on your calculator. So step 1, type that problem in. So we need to type in 34.79 degrees. So 34.79 34.79. And to get the degree symbol, it's second apse number 1. So there's step 1. You type the problem in. So type in 34.79 degrees. Step 2, do second apse number 4. So second apse number 4. So that triangle DMS means it's going to take that problem and it's going to convert to degrees, minutes, and seconds. Notice the cursor is flashing. To get your answer, hit enter. And there is our answer. It's 34 degrees, 47 minutes, 24 seconds. Now if you got 0 degrees, probably you have your calculator in radian mode. Okay, so write down exactly what you saw on the calculator screen. So for number 11, our answer is 34 degrees, 47 minutes, and 24 seconds. And I'll do one more with you. So looking at number 12, step 1, type it in first. So we need to type in 134.254 degrees, so second apse number 1. And then after you typed it in, do second apse number 4. And now it's going to convert to degrees, minutes, and seconds. And notice this time our seconds has a decimal place. That's fine because it didn't say to round. So just write down exactly what you see on the calculator. So 134 degrees, 15 minutes, and 14.4 seconds. And I want you to do the next two. Do 13 and 14. What did you get for 13? Negative 15 degrees, 15 minutes, and 54 seconds. What about the number 14? Negative 194 degrees, 14 minutes, 44.88 seconds. Questions on that section? As long as you know the correct buttons to type, you're in a good place. Okay, this next section, it says solve to the nearest 10,000. So if we're rounding to the 10,000th place, how many decimal places will that be? 4. So we need 4 decimal places. Now, on your calculator, if you notice we have sine, cotangent, cosine, we have tangent, secant, and cosecant. Your calculator only has the 3 main trig identities, sine, cosine, and tangent. So number 15, we have a sine button on the calculator. So all you have to do is hit the sine button and then type in that angle, 34 degrees, 16 minutes, 48 seconds. So where's the sine, cosine, and tangent button?
Right above.
It's 2 rows above 7, 8, and 9. So find 7, 8, and 9 and go 2 rows above that. So number 15, the sine button is 2 above the number 7. So hit the sine button. Now notice after you hit the sine button it opens up a parenthesis. So make sure your angle goes inside the parentheses. And our angle is 34 degrees, second apse number 1. 16 minutes, second apse number 2, and 48 seconds. And for the seconds, it's alpha plus sign. Now again, it opened up the parenthesis for the angle, and when I'm finished typing the parenthesis, I need to close that. When I'm finished typing the angle, close the parenthesis. And they said to round to the nearest 10,000, so we need 4 decimal places. So I see .5632. Behind that is a 3, so does it round up or stay the same? Stays the same, so our answer is .5632. So make sure you round appropriately. So .5632. You have to have 4 decimal places, not 3. Now number 16, we have cotangent. Do we have a cotangent button on the calculator? No, the only one we have is tangent. But this is a reciprocal. So what I would have to do, cotangent is the reciprocal for which one? Tangent. So when I put this in the calculator, I have to do 1 over tangent of that angle. So tangent of 16 degrees, 54 minutes. So if you have a reciprocal identity, you'll have to do 1 over the identity it's a reciprocal for. So if it's cotangent, you'll have to do 1 over tangent. If it's secant, you'll have to do 1 over cosine. If it's cosecant, you'll have to do 1 over sine. And do you have an answer for number 16? I got something different. 3 point what? 2914. That's 3 rounds up. Next one, number 17. That one is cosine. So hit the cosine button and type in the degrees. Do you have number 17? I agree, .8455. I want you to go ahead and do number 18. Hit the tangent button and type in 58.67 degrees. Do we have an answer for number 18? 1.6428. I agree, 1.6428. Now for number 19, do we have a secant button on the calculator? No, so we'll have to do a reciprocal. So secant is the reciprocal for which one? Cosine. So in the calculator, you'll have to do 1 divided by cosine of 52 degrees, 16 minutes, and 38 seconds. 1.6344. I agree, 1.6344. And number 20, do we have a cosecant button on the calculator? No. So you'll have to use a reciprocal. So cosecant is the reciprocal for which function? Sine. So you would have to type in 1 divided by sine of 156.4 degrees. 2.4978. I agree, 2.4978. Questions on that section? So if it's not sine, cosine, or tangent, you'll have to do a reciprocal. Next section, it says use a calculator to find theta to the nearest whole degrees. And this is the second function. So this time, we're moving in the opposite direction. This time, they're giving us the answer to 4 decimal places, and we have to figure out what is the angle that produced that value. So if they're giving you the answer for the sine, this is called arc sine. So if they give you the answer, you'll have to use the second function of the sine key. So when you put this one into the calculator, you'll have to do second, and then hit the sine button. And you want to take the second sine of .4289. So second sine of .4289. And once you hit second sign, what pops up on the screen? Sign to the -1. And what does -1 power mean? Inverse. Let's see, so second sign, and then type in 0.4289. I'm going to close the parenthesis. And they said to round to the nearest whole degree. So right now I have 25.39777 degrees. Rounded to the nearest whole degree. Would that round up or stay the same? Stays the same. So for number 21, the answer is 25 degrees. So make sure you round the way that they said. So they wanted to the nearest whole degree. Next one, number 22. They're giving us the answer for cosine. So this answer is called the arc cosine. So if they give you the answer, you have to do second and then cosine, and then type in the number, 0.7246. What was it? 44 degrees, do we agree? And then number 23, what is the 6.8218 called? Arc tangent. So in the calculator you would do second tangent of 6.8218. 82? Do we agree? Okay. Questions on that section? Okay, moving on to the next section. Now it says use a calculator to find theta to the nearest second. So we're going to do the same process we just did, but now we're going to take it one step further. So after you get the initial answer, then you need to do the second apps, and then number 4 to convert it to degrees, minutes, and seconds. Remember that's the DMS? So second apps, number 4. So do the same process. So do second sign of 0.8104. So second, and then sine of 0.8104. Then after you do that, step 2 would be second apps, number 4. So that's what you need to type in. So second sine, 0.8104. Now I'll do this one with you. I'll let you do the rest. So second sine, 0.8104. And it will give you 54.1 degrees. But we need to round to the nearest second. So you need to take that answer and convert to degrees, minutes, and seconds. So now type in second apps, number 4. And after you type in second apps, number 4, it says A and S, then the triangle, degrees, minutes, seconds. What does A and S stand for? So it's taking my answer that was 54.1, and now it's going to convert that to degrees, minutes, and seconds. And when I hit enter, let me write down what's on the screen. After I hit enter, I have 54 degrees, 8 minutes, and my calculator said 6.111 minutes. Not minutes, sorry, that was seconds. But I need to round to the nearest whole second. So you cannot leave a decimal with your second. So this would be 54 degrees, 8 minutes, instead of 6.11. Does that round up or stay the same? Stays the same. So this would be 6 seconds. Okay, I want you to do 25 and 26. same process, we'll have to do secant, and then cosine of 0.1209. After you get that answer, do secant, and then half, and then number 4. And what did you get? 83 degrees, how many minutes? 3 minutes. And 21 seconds. Do we agree? Okay, number 26. Same process, we'll have to do secant. This time we'll have to do tangent of 1.406. And then after you get that, do secant at number 4. And how many degrees did you get? 54 degrees. How many minutes? 34 minutes. And how many seconds? 41 seconds. We agree? Okay, the last 2. We made it. Now this section says use a calculator to find theta to the nearest second. Oh, we added problems. Okay. 27 and 28. Do you have the answer for 27?
Yes.
What is it?
24.
54 degrees.
54 degrees.
Is the answer 24?
8 minutes.
8 minutes. 6 seconds.
24.
Is that the right answer for 27?
Yeah.
54 degrees, 8 minutes, 6 seconds. What's that for 28?
12 degrees.
12 degrees,
3 minutes.
3 minutes,
6 seconds.
6 seconds. Okay, now to the last section. Now we finally made it. Here's 29 and 30. So it says sketch a right triangle, find the missing side, and the other 5 trig ratio. So make sure if it says sketch a triangle, make sure you do that. So here's my right triangle. Now theta could be the top angle or bottom angle. It doesn't matter where you put theta, top angle or bottom angle, you get the same answer. I'm just going to put it in the bottom. Now, they gave us cosine. Cosine is adjacent over hypotenuse. So I need to mark the adjacent side as 3, and the hypotenuse is 5. Now, they did tell us to find the missing side. If you have a missing side, use Pythagorean theorem, or hopefully you know your triples. And this would be a 3, what? 4, 4. 3, 4, 5. So hopefully you know those triples, like 3, 4, 5, 5, 12, 13. Hopefully you know those, so it'll save you some time. Now, you need 6 answers. You need the sine of theta. You need the cosine of theta. You need the tangent of theta. And you need the reciprocal. So what's the reciprocal for sine? Cosecant. Remember, C and S are paired together. And what is the reciprocal for cosine? Secant. And the reciprocal for tangent? Cotangent. Now, they'll give you one of the answers. So they'll give you 1 out of the 6. So they gave us cosine. The answer for cosine is 3/5. So if the cosine is 3/5, what is the secant? 5/3. You flip the fraction. Now for the sine, how do you find sine? Opposite over hypotenuse. So what would the sine be? 4 over 5. So what would the cosecant be? 5 over 4. How do you find tangent? Opposite over adjacent. So what would the tangent be?
4 over 5.
4 over 3. And what would the cotangent be? 3, 4. So once you find sine, cosine, tangent, flip the fraction to find the reciprocal. Now the last one, number 30. This time they gave us the cosecant. Cosecant is the reciprocal for which trig identity? Sine. How do you find sine? Opposite over hypotenuse. So this is not opposite over hypotenuse. It's flipped. It would be hypotenuse over opposite. I'm going to sketch my right triangle right here. And just like that previous example, I'm putting theta at the bottom angle. If you put it in the top, that's fine. Doesn't matter, you'll get the same answer. So now mark what they gave us. So the opposite side is 2, the hypotenuse is 3. Is that one of the Pythagorean triples? No. So we'll actually have to do Pythagorean theorem. So a squared plus b squared equals c squared. So a squared plus 2 squared equals 3 squared. So a squared plus 4 equals 9. So what does a squared equal? 5. So a is going to be square root of 5. Now, if this were square root of 40, would you leave square root of 40? No. What would be the simplified form for square root of 40? 2 square root of 10. Keep that in mind when you do your homework. But this one is fine. Square root of 5. Once you have all 3 sides, then you can find your sine, your cosine, your tangent, and then their reciprocals. And what is the reciprocal for sine?
Cosecant.
And we use CSC for cosecant. And what is the reciprocal for cosine?
Cosecant.
Secant. And what is the reciprocal for tangent?
Cotangent.
Cotangent. And they'll give you 1 out of 6. And they gave us the cosecant is 3 over 2. So what is the sine?
2 over 3.
2 over 3. How do we find the cosine? Adjacent over hypotenuse. So what is the adjacent side? Square root of 5. And the hypotenuse is 3. So for the secant, what would the secant be? 3 over square root of 5. Can I leave a radical in the denominator? No. Rationalize that. Then multiply both numerator and denominator by square root of 5. So in simplest form, that would be 3 square root of 5 over 5. How do you find tangent? Opposite over adjacent. So what's the opposite side? 2. What is the adjacent side? Can I leave my answer as 2 over square root of 5? No, but leave it like that for a second. Because I want to step over here and find the cotangent. So if the tangent is 2 over square root of 5, what would the cotangent be? Square root of 5 over 2. So let's get that one knocked out of the way. Now go back over here to tangent and let's finish simplifying that. And rationalizing that, we'll multiply both the top and bottom by square root of 5. And I'm kind of out of room, so I'll just bring it down here. So this would be 2 square root of 5 over 5.